And welcome again, dear Partisia community. Here we have Bruce and myself, Tiago. We're going to be discussing a very, very hot topic in the entire industry, one that has been front and center of probably one of the challenges of our industry in terms of worldwide adoption. When you hear that phrase, how are we going to onboard the next billion users? Well, quite simply, it's impossible because there's this bottleneck. So basically, we're talking about one of the pillars of the trilemma. So to introduce the subject of scalability and how Partisia Blockchain has a solution for that, I'll hand it over to Bruce.
Yeah, hey guys, I'm back at beautiful Aarhus, Denmark. But yeah, scalability. This is it's a huge topic. So what are we talking about when we talk about scalability? I think Thiago, you really explained it really well. It's about how do we onboard so many people. I'm sure a lot of the audience has heard of things like optimism or zero knowledge roll up, so on and so forth, to help make transactions faster. Ultimately, in the end, that's what scalability is, to be able to scale to the amount of users that they want to be able to support, and also be able to support a very fast transaction, even if you have so many different users. And ultimately, in the end, it all boils down to TPS, transaction per second. How much transactions per second can a blockchain handle?
Mm-hmm.
And this topic is pretty interesting to me when I first heard about it. When I first heard about how Partisia blockchain tackles this, the architecture around it, I was like, that's pretty interesting because I've actually heard of the term sharding before, right? So sharding is one of the technology architecture in the blockchain space um, that has been used to try to scale the chain to be faster and be able to handle more users. And so I've heard the term sharding before, but not in the way that it is being used in the blockchain industry. Sharding is actually a database term. And so when I saw the architecture in Partisia blockchain mirroring the true definition, what I consider to be a true definition of what sharding is, I was like, yes, this is exactly what sharding really means.
So going back to Bitcoin generation one blockchain,
Yeah.
I can't remember the exact number, but what is it able to handle? Is it like 12 transactions per second or 15 or something like that? So that
Something
means
like that.
so that means that, and each block has 10 minute time between each block. So 10 transactions per second, that means that if there's 20 or 30 people, then the only way for you to prioritize your transactions to make sure that you make a payment in the relevant amount of time that you want it to happen, you would increase your fees. So that's when the fees wars started to happen, and people would use Bitcoin. Then on a Friday night, something would happen where thousands of users decided to do transactions, maybe a huge price swing. Then all of a sudden, your transaction would get stuck like 2, 3, or 4 days. And that's why eventually there was this proposal called RBF, replaced by fee, where you could send a transaction, but if it got stuck, you could replace it with another transaction with a higher fees. But then the person who suffers is the user, because then all of a sudden, to make a $10 transaction, you would need a $20 fee, which makes absolutely no sense at all.
Yeah.
Then came the layer twos, Ethereum, the generation 2, Ethereum, for example. But then the infamous CryptoKitties incident happened, where this just one dApp was able to clog the entire Ethereum network in much the same way and dramatically shoot gas fees to $700. And this was like years ago. And that's when the first layer twos were created. So people thought, okay, so how can we deploy a system on Ethereum that we can handle thousands and thousands and thousands of transactions per second and yet inherit the security of Ethereum and the decentralization of Ethereum? So they created a layer 2, which is basically a sub network within the Ethereum network that would process all this volume of transactions and then settle on the main layer 1. L1 is a layer 1. But that obviously is not ideal, because in essence, you have to hop from one chain to another. And just for the general user, it's just one more hurdle to go through. So this is why I'm particularly excited, and going back to sharding and handing it back to you, I'm particularly excited for Partisia because we are able to deploy applications with users at scale without needing a secondary layer to absorb all these users. And just to add to this, there's been talks about adding sharding to the Ethereum network since 2015, if I remember, when they started to figure out the scalability issues. So I'm really excited about Partisia because it is, as you mentioned, the first blockchain that actually uses sharding in its core waveform to actually achieve that massive throughput that we've been talking about.
So yeah, why don't we jump into the slides then?
Yeah, let's go.
Okay, so this is Partisia Blockchain's contributions to addressing the scalability aspect. And so let's just, initially review what a blockchain really is. I'm sure, most of the listeners, most of the viewers probably already know what a blockchain is, but it's essentially a public ledger system where, every single transaction gets created as a block, and then it gets appended to the end of a long chain of blocks. So you have the first set of information here, which is called the genesis block, and then block number 2 gets created and gets appended to the genesis block, block 3, block 4, block 5, and as more transaction information or history of transactions gets confirmed, it gets added into the end of the block. And so you have all of these different validators that are confirming the information. And then once the block is confirmed by the validators, it gets appended back into the chain. In these kinds of systems, scalability becomes an issue where when you begin to grow from 10 users to 100 users, to 1,000 users, to 10,000 users, 100,000 users, 1,000,000 users. Well, it takes a lot of processing power to continue to be able to create these blocks and then append it to the end. And as you noted, or as you stated at the beginning of the call, in the introduction, he talked about blockchain, then talked about Bitcoin and how in Bitcoin, when it first came out, it took a long time for even small amount of data to be confirmed and put at the end. How can you scale up to 1 million, 10 million users, 100 million users? So the blockchain industry and different protocols that have come out has come up with different ways of trying to tackle scalability, and one of them is sharding. And this is the common form of addressing scalability. And sharding basically means that instead of creating these blocks one at a time, you would parallel process or parallel create the blocks. And as the blocks become validated or finalized, they would get finalized in parallel. And then as soon as they're finalized, it goes to the end of the chain and it gets appended to the end. There are other technologies that are out there, things like ZK rollup or optimism, dynamic state sharding. They all work in different ways to help scale the existing single chain. And so like things like these kinds of sharding architecture will speed up the finalization of the blocks so that it can be placed at the end of the chain as soon as possible. So what is the definition of sharding? Where does the word sharding come from? And the way I traditionally understood sharding to be is from the database industry. It's used often to be able to scale, just like how it's being used in the blockchain industry. It's used to scale the amount of data that a database has to process and confirm. And it was actually created, by a video game company. I don't know if you've ever played any kinds of online games, But the Ultima Online is a video game that was very popular, I think, in the 90s.
I remember 2000 issues. I perfectly remember
Okay.
the game, but I actually never played this one.
Yeah, I think it was very popular, and at the height, I think they had like 100,000, which is very small compared to I think the new video games that are out there. But back then, it was very difficult to scale that many users interacting in their virtual worlds. So, the video game company created a term called sharding, and it's a scalability method where you would create instances, different databases that comprises of different worlds. So you're kind of dividing up the worlds into different databases, allowing parallel processing of interactions that are happening in those worlds. And now the worlds, 1, 2, and 3, as an example here, also needs to interact with each other. So as an example, if a user in world 1 needs to send, that their items, let's say, to some user in world 2, you need a way for information to be transmitted between world 1 and world 2. And this sharding architecture provided the methods to be able to do that. And this technique caught on and actually was implemented by a lot of other database systems like MySQL, Oracle, Oracle database, not the Oracle from a blockchain industry perspective, Microsoft SQL servers, et cetera, large database systems um, adopted this technology, and the word sharding became very common in the database world. But if you take a look at the architecture of the database sharding and the architecture of blockchain sharding, you can notice the difference. So Partisia Blockchain's complete sharding architecture really went back to the core definition of what sharding really means in the database world. So if we take a look at a blockchain, at its core, it's just a big set of information, which is a database. So blockchain really is a database, right? And in most, probably all blockchain technologies that are out there, you have a single blockchain, which means you have a single database. And though we use the word sharding to create multiple different blocks in parallel, it still, in the end, gets appended to a single database or a single blockchain. So when we architected our blockchain, we went back to the true definition, in my view, the true definition of what sharding really is. In our architecture, when we say a shard, it's actually a blockchain, a full-fledged blockchain. So in our architecture, you can see we have a governance shard, shard 0, shard 1, and shard 2. Each of these shards are independent blockchains or independent databases, just like how it is defined in the database sharding terminology. And each of these shards or each of these blockchains are independently creating blocks, generating blocks, and appending it in parallel, in true parallel processing, independent of each other. And then we have a unique messaging system that transmits transaction information from one shard to another shard. So as an example, let's say my account was in shard 1 and Tiago, your account was in shard 2. And I want to send you some, Ethereum, right? Because our blockchain supports Ethereum. I want to send you some Ethereum. My account information lies on shard 1 or blockchain 1. Your account information lies on shard 2 or blockchain 2. Then we have a very unique messaging system that transmits the transaction message from my account in shard 1 to your account in shard 2 to allow for the completion of that transaction. So another unique feature about Partisia blockchain is that not only do we have multiple different independent shards, But in the event that there's congestion, let's say that there's even more people that are transacting in Partisia blockchain, and we need to increase capacity. There's a dynamic sharding architecture that allows the creation of a new shard and then be appended into the unique messaging protocol. And this happens dynamically. It detects congestion and it is able to add another shard into the system, allowing for additional scalability. And this is what we mean when we say we actually have the capacity, the architecture has the capacity for infinite scalability. Now, when you say infinite scalability, it's like, what are you talking about? That's impossible. And yes, there's probably impossible to create infinite shards because there's always resource constraints in the end, right? But theoretically, we can. Now we layer on top of that a speed of light consensus model, right? So it's not just a matter of adding additional parallel processing of blocks. We actually also have to finalize these blocks as quick as possible. So we layer on top of our complete sharding architecture a speed of light consensus model. And the way this works is that we have a committee, right? We have a committee of nodes that is producing blocks and verifying blocks. And then the committee selects a proposer, somebody who's going to now say, hey, I'm going to select this particular validator to produce blocks for shard 0 or blockchain 0. The proposer validates transactions that are happening and creates a block. And then the proposer or the node that's been selected to produce the block for shard 0 floods the block to the rest of the validators. The validator then validates the block and creates what's called a proof of verification and signs that block. And every single node then floods the signature. Once two-thirds or more signature is received by all of the node operators or all the validators, that block is then considered final, and then it gets appended into the end of shard 0. And all of these transactions, all of these processes are happening in parallel. So shard 0 is doing this independently of shard 1 and shard 2. And all of this finalization happens at a blink of an eye, basically. And it is only limited by the amount of time that it takes for a particular transaction to traverse from one geographic location to another geographic location of where the other nodes are. So if you take a look at some comparisons with other blockchains, right? And in the beginning of the conversation, we talked about two things that are important in scaling to be able to support a large number of users. We talked about how quickly you can transact and how quickly you can finalize a block and how many blocks you can finalize at the same time. So you have a parallel processing of blocks that's important. And then the second important part is how quickly can you finalize the actual block. So you can see here in our comparison chart, Partisia Blockchain, our consensus model is called proof of trust. Our TPS currently is 3,000 transactions per second with 3 shards. And as we spoke about, we can always add additional shards as congestions come in. Our average transaction fee is 1 cent per transaction. And this is a stable transaction fee because our fee model is based on USD and is not based on our MPC token. Our block creation time is 0.3 seconds. And this 0.3 second is really talking about how long does a message from one node need to traverse through physical geography to the other nodes. And finalization really is immediate. And as we spoke about, our sharding is unlimited. We can create as many shards as we want. And so if you add all of those things together, you can see how our chain from a scalability perspective differs from other chains, and not just from a not just from a transactions per second perspective, but from a cost perspective and how quickly we can finalize blocks. It really shows what a difference it makes when you actually go back to the original definition of certain things.
Well, first of all, thank you for that, Bruce. It's always really, really insightful when sometimes complex terms, because I heard of sharding for the first time when, as I mentioned before, when Ethereum communities first started talking about it. And, these were developers just tech talking with each other, and I just could not grasp a thing. And during the years, I heard about sharding here and there, and I tried to look at some videos here and there, and I just didn't get it. And then finally, I did understand the concept, and it was thanks to you. So thank you very much for making that presentation. It really helps to understand how beautifully designed Partisia is. So the prowess of blockchain is incredible, but now we need better solutions. And Partisia, and obviously in my biased opinion, and I'm sure in your biased opinion as well, is the first true generation for blockchain, precisely because not only the privacy aspect of it, but because of the inbuilt from the basic design to be able to scale linearly with new users.
Yeah, I think that makes perfect sense. And yeah, I was also, like you said, I was blown away by Partisia Blockchain's architecture and the careful thought that they placed before the creation of the system and the vision that they had. It wasn't just some copy of, Ethereum or some other copy of another blockchain.
And just hack a solution into make it the next greatest blockchain, whatever, because of this new feature. Yeah, exactly.
Yeah, exactly. It was carefully thought of, and the architecture really fits into the vision that I think the founders had when this was designed. So yeah.
All right, I think this concludes this presentation. Once again, I'd like to thank you, the people viewing this. Thank you very much for your participation. We will have more content moving forward, so stay tuned. And thank you very much for participating, and we will see you soon.
Thanks, guys.